Hi dear students, today we shall discuss the new chapter surface areas and volumes. Surface areas and volumes. So this chapter you have already studied in your earlier classes. So let us see some formulas so that you have studied already. So the first one is CSA of cuboid, that is 2 into LH plus BH square units. So since it is area, you can write them as square units. So here is what? 2 into LH plus BH. You know cuboid already. So cuboid, it is nothing but in this, first I will draw a rectangle. Then I will form the cuboid. So it means 3 dimensions will be there. Those are L, B, H. Okay. So means here it is the length. I will take this as L. This is L. Next breadth. So breadth here is, this is the breadth. So here this I will take it as breadth, and height. Height of that cuboid I will take it as H. Okay. If you consider a room, so the length, breadth and height all must be different. Then you can say it as a cuboid. If all L, B, H are equal, then you can say it as cube it is. Okay. So 3 dimensions are there. Then you can take it as a cuboid. So the best example for this is a matchbox. You can take matchbox. There the length is different. Okay. Then the breadth is also different. The height is small one, like this. Okay. So that is the first example for cuboid. So I said here it as a CSA of cuboid. What it is CSA? So 2 sides are removed, means top and bottom are removed. Okay. So if you consider the classroom, or you can take a room with 3 dimensions, different dimensions, L, B, H. So top and bottom are removed. Then the remaining will be the 4 walls. Okay. So here the bottom will be, so you can take length one side, then another one is breadth. So this area is, bottom area is LB. So one LB is removed. And top of the area, so that is also LB it is. So top area. Okay. Terrace you can take it as LB it is, area. So because length and breadth will be removed, so LB plus LB, 2 LB get removed. So remaining is 4 walls. So that here LB have not written here. So in TSA you can get 2 LB, but here no LB because top and bottom are removed. So remaining is 2 into LH plus BH square unit. That is CSA of the cuboid. The next one, TSA of cuboid. So already I explained you. So if you consider a room of 3 dimensions, L, B, H, so top and bottom and 4 walls. So all 6 spaces are included. So then the TSA I can mention it as 2 into LB plus BH plus LH. So in this one, so all the 6 spaces are considered. So top and bottom is not open, not closed. Sorry, it is not open, means all 6 spaces are there. Okay. Then the area of this TSA of this cuboid is 2 into LB plus BH plus LH square units. Okay. Now let us go for cube. So this cuboid will become cube when these 3 dimensions will be equal. Means I will draw like this. First you draw square. Okay. All 4 sides must be. To draw cuboid, you must first you draw a rectangle. Now I will draw in this way. First, so this is cuboid. So here all the 6 faces are equal. Then you can say it as what? Cube it is. Okay. Now here I have taken A as the edge. Okay. So height, length, breadth all are equal. I mention it as a edge. A is the edge of the cube. Now here CSA of cube means top and bottom of a cube is removed. Okay. So let us consider a room of length, height, breadth are equal. You remove the top and bottom, the remaining will be 4 walls. Okay. So the area of that 4 walls will be 4A square when LBH are equal only. Okay. Now if suppose top and bottom, both top and bottom are considered, then the area will be 6A square. Okay. So TSA of cube is 6A square units. So CSA of cube is 4A square units. Since it is area, the unit will be square units. Okay. Now we'll go for a cylinder. So cylinder is nothing but a, so already we know the diagram for that. You can take any pipe, PVC pipe is there, na? That you can take it as a cylinder. Okay. So here, so this will be the cylinder. Okay. Now here, so it is what? Height. Height will be this one. This is the height of the cylinder. Okay. So H. Otherwise you can take a CSA of the cylinder is there. Not this is. This is the height. This will be the radius. Okay. And this will be the height. Length will become the height. So length of the pipe. So length of the pipe will become the height of the pipe or cylinder. Okay. You cannot take this as a height. So this is the height. This will become a diameter of this circular hole, you can say. Okay. Circular area it is. Diameter it is. So height will be this one. Now here, CSA cylinder consider. CSA cylinder is 2 pi RH. So here R is the radius of the cylinder and H is the height of the cylinder. So here, what it is CSA? Means both the side open is there. Okay, you can take pipe, both the side it is open. Okay, if you pass the water, so the water will come off, they come outside. So means the pipe is open. On both sides the pipe is open. Then that will become a CSA of the cylinder. CSA of the cylinder. So that area will be 2 pi RH. Okay. So like this. So this side and this side both are open. So means this curved surface area only remains. Okay. So those two open area is not closed. That is open it is. Okay. Now CSA of cylinder is 2 pi RH. Now TSA cylinder is what? So if suppose these two opens are closed, these two circular holes are closed. Okay. So means if you consider pipe, both the holes are closed, then two areas are extra. So this is pi r square and this is pi r square. Initially the curved surface area of this is what? 2 pi RH plus this is pi r square area. So this is pi r square plus pi r square. That will become 2 pi r square. In this one you can take common as 2 pi r. Remaining is what? 2 pi r taken outside, H plus R. So this is what the TSA of the cylinder. 2 pi r into R plus H. Okay. So CSA cylinder is 2 pi r H. TSA cylinder is 2 pi r into R plus H square units. Okay. Now the next one is a cone. Already I hope you saw that cone. So they will give, what is that? In ice cream they will give na. So that is in this way. Okay. This is the cone. Otherwise that cone will be in this direction also. Opens down side. Both are cone only. Okay. Now what it is? CSA of a cone. If this area is opened, top is opened. If this is open, so remaining is this one only. Okay. So this area will become what? CSA of cone, that is pi RL. So L means what? It is slant height. Okay. So this is what? Slant height. So this is R and this is what? Height. So this I will take it as a slant height. Okay. Here you can apply Pythagoras theorem here. So it will become what? L square is equal to R square plus H square. Now here L is equal to square root of R square plus H square. Okay. Slant height L is equal to root of R square plus H square. Now this is the radius and this is the height of the cone. So here this top is open. Then you can say it as a CSA of cone, that is pi RL. R is radius and L is the slant height. Now let us go for TSA. So TSA means what? So this is closed. Okay. So this is closed. So then you can take it as a TSA of cone. So CSA it is what? Pi RL plus. Now this is closed, means one circular area is there. So that is pi r square you can take. So this is what? Pi r square. Take common here, pi r. Inside is what? L plus R. Okay. So this is what? Pi r into R plus L. And this is the TSA of the cone. Okay. Pi r into R plus L square unit is the TSA of cone. So this is closed. Okay. One extra circular area will be there. That is plus pi r square. CSA plus pi r square will give us a TSA of the cone. Okay, this is all about cone. Now I'll go for hemisphere. What it is, how it will be the hemisphere. You already saw the ball. You cut the ball into two equal parts. Okay, so first you cut the ball into two equal parts, you'll get two hemispheres. Two hemispheres. So if suppose the ball is, if the ball inside there is no, inside the ball only air is there. Okay, it is empty. It is inside the ball empty. You cut that ball, so that will be in this way. Okay, inside it is open. So this base is not closed. Then that is will become CSA of hemisphere. Okay, so if you cut the ball will be in this direction. Okay, so inside everything is open. If you close this, it will become TSA of hemisphere. TSA of hemisphere. If you remove this, CSA of hemisphere. Okay, so CSA of hemisphere will be what? So 2 pi r square. 2 pi r square. So I will draw like this. This I will take it as what? TSA of hemisphere. Okay, so here what? The base of the hemisphere is removed. So then it will become a CSA of hemisphere, that is 2 pi r square, where r is the radius. So this I will take it as what? R. So radius of the hemisphere. If suppose this top or base is closed, if this base is closed, then again one more circular area is added. Initially it was what? 2 pi r square plus, now this circular area is added, so it will become what? Plus pi r square. 2 pi r square plus pi r square, it will become 3 pi r square. That is TSA of hemisphere. TSA of hemisphere, that is 3 pi r square. CSA of hemisphere is 2 pi r square. TSA of hemisphere is 3 pi r square. Okay, so if the top or base of the hemisphere is closed, so then it will become TSA. The top or base of the hemisphere is removed, then it will become CSA of hemisphere. Then the last one is only sphere. So you can take a ball. So there you cannot consider CSA or TSA separately. So this generally I can say it as surface area of sphere. Okay, instead of saying TSA, you can say directly it as a surface area of sphere. That is what? 4 pi r square. Okay, so it will become what? 4 pi r square. You take the best example for this is ball. Okay, so this is what? All these, the unit must be square units. Okay, first you note all these formula. There are some other formula related to volumes. We will note them afterwards. Okay, now we shall discuss combination of solids. Okay, so separately we have studied the cuboid solid one. It is one solid. So then what is that? Cube is another solid. Separately in the previous class we studied all these solids separately. But now we are going to study these solids in combination. Okay, so let us discuss them, how it will be. Now let us discuss surface area of combination of solids. So let us take this as petrol tank, or you can take it as a diesel tank. Already you observed this type of tank. Okay, so here, so this will be in this form. So here it is cylindrical type. Okay, for this cylindrical type there are two hemispheres attached on both the sides. So this is one hemisphere and this is another hemisphere. Okay, so this is what? A combination of solids. There are three solids, one hemisphere, and this is one cylinder, and this is one another hemisphere. Okay, this is combination of three solids. Okay, now what is the area of this solid? So new area of surface area of new solid. This one I am going to write surface area of new solid. So means the total solid this is. Okay, combination of solids are there. Now what is the area for this solid? Now there are two hemispheres already I said. First I will consider this hemisphere. So area of this hemisphere I have taken it as curved surface area of hemisphere. Why I taken only CSA? Why I taken only CSA? Because here, so inside this is open, this is not closed. So this is what base of the hemisphere is not closed, because so here also petrol or diesel will be there. Okay, so this is open. That's why I have taken this area as CSA, not TSA. If this is closed, then I can take it as TSA. Okay, so this open is there, so I'll take it as hemisphere plus. Now again I'll go for this cylinder. Okay, so for this cylinder also, so these two ends, circular ends, are kept open. So for that reason I will take it as CSA of cylinder. This I can take it as what? CSA of cylinder plus. So here both the ends of cylinder are kept open, so that I can take it as CSA. If these two are closed, then I can take it as TSA. Now the third one, this for this solid. This is also hemisphere, and this circular base is also kept open. So because diesel or petrol will goes here. Okay, so this is kept open. That's why I can take it as a CSA of hemisphere. So this I can write as what? CSA of hemisphere. So otherwise directly I can write 2 into CSA of hemispheres. So because these two are two hemispheres of equal radii. So this length, diameter and this diameter both are equal. Okay, so that's why I can take it as a 2 into CSA of hemisphere plus CS of cylinder. Okay, so this is what? Surface area of a new solid. So this solid is combination of 3 solids. So the surface area of this new solid is this one. Now I will take one toy. So I hope you saw this toy. When you are in a child, you play this toy. Okay. So this I'll take. Okay. Now, so this is one solid, new solid. This is the combination of what? Here cone is there. The cone will be in this way. Okay. This is the cone. For this cone, another solid is attached. That solid is hemisphere. Okay. This is what? Hemisphere. So here the surface area of this new solid will be curved surface area of hemisphere. Okay. So surface area means outside, not inside. I am going to find inside. Okay. So not inside, it is outside only. So this is what? Surface area, curved surface area of hemisphere plus curved surface area of cone it is. Okay. This is a combination of two solids. One is hemisphere, another one is cone. So total surface area, the surface area of this solid will be CSA of hemisphere plus CSA of cone. Okay.